Namaste everyone, and good morning, good afternoon, and good evening to everyone. Now, let's start. So, how many of you have played chess? Obviously, all of you, chess, all of you, right? Yeah, almost all of you would have played the chess. Now, another question: how many of you have played the chess with in computer or mobile? Many of you, majority of you again. So, so the question is, how does computer know about the chess? Have you ever thought about it? Hmm? Yes, you want to say something, Dishan? Okay. Yeah, tell me.
Maybe someone did program it like that.
Someone-
That it knows how he plays chess, and then he'll program it that he plays like he wants, but only within the rules.
Correct. You are right, Dishan. You're absolutely right. See, I'll show you one thing. I'll share my screen here, and you'll be able to see that. So, can you tell me which game is this? Hmm?
Tic-tac-toe.
Correct. Tic-tac-toe. That is the easy game. No? You all would have played that. How many of you have played this? Almost all of you. So you know that you have to place X and O. Let's play that game. You know that you can play this game with Google. Do you know about that? No? I'll show you. I'll share my screen and you'll be able to see that. Yeah. So here you see, here is a grid. And if you see, I will change. These are the labels: easy, medium, impossible. That means hard, and play against a friend. That means two friends, not a computer. So at present, I am playing against the computer. I'll set this to easy, and now you see what happens. Okay, so I'll choose to be O. Okay, so X turn is first. I'll place O somewhere now. So let's do it here. O. Now here is the X. I'll do O here. And where should I do it? You know, right? You know what should I do in order to win this game? I'll do it here. One, right? So O is the winner. Let's restart the game. I'll again use O. And so now this time X has learned and it has made the X in the middle. Okay, I'll do it here now. O, then O. Now, see, I have two possibilities. There are four possibilities. One, two, three, and four. If I put O here, what will happen? In the next move, there is a possibility that X will place the mark here and X will win. Am I right? Let's see if they know about it. So I'll do it here. Oh, oh my God. Don't you think computer is dumb? Where the computer should have placed here, no? It should have placed here. If computer had placed X here, it would have won. So now there are two possibilities, and I'll place it here. And oh, one more time. Okay. Now let's change the label. I'll change the label from easy to medium and restart the game. So here I'll start with O again. X is turn. I'll place O here. Now I have 1, 2, 3, 4, 5, and 6 possibilities. 6 possibilities to place my O. I'll put that here. But now computer has become smarter. See, it has What it has done? It has blocked my way, right? So now I'll do it here. Oh, one more time. See, it has placed the X here now. So my way is blocked. Okay. So I have two more possibilities. But with any of this possibility, can O win? Now, can X win? No. Can X win? Yes. X can win, right? If X is here, so if I don't want computer to win, I should put O here. And still X won. Right? So earlier it was not winning. X was not winning earlier, but now it is winning. Let's try one more time. I'll change the level from medium to impossible, that is hard, and restart the game. And here I become O again. O, X, O, X, O. 1. So X1, how? So X is knowing, no, now. Earlier it was not winning, but now X is winning. Let's do one more time. O, I'll do here. Now I have the possibilities. Now let's talk the possibility. 1, 2, 3, 4, 5, 6. Where can I win and where can computer win? If I place here, may I win? No, right? There is no possibility I can win placing here. Here, yes, here, yes, here, yes, here, yes, here, no. So these two positions are not my winning position. Am I right? And let's talk in terms of computer. If I place here, will computer win? Yes, it will block, right? Will it block? Yes, it will block. Here, yes, block. Here, yes, here, yes, yes, yes. All these positions are blocking. So instead of these two, I will choose here. Okay? And now if I put here, any loss to me? Yes, here computer will fill in will. O, X. And now what should I do in order to block computer? Any of these things are fine. If I place here, it's fine. If I do it here, it's fine. Draw. So if you observe, this game is about the possibilities, right? How many positions you have to start with? When you start the game, you have 9 positions. 3 into 3, that is 9. Am I right? So to start with, you have 9 positions, then you have 7 positions, then 8 positions, 7 positions, 6, 5, 4, 3, 2, 1. And if you make any mistake in between, you lose. Otherwise, normally what happens in XO game? Draw or winning? What happens normally? Draw or winning? Yes, Satyam?
Win.
Win? Okay. Abhinam, what happens normally in the game of XO?
If we play against people who are very intelligent than us, they would win. And if we play with people who are equal to us, it will draw. And if we play with people who are not intelligent, then we would win.
Nice. Very, very good answer, Abhinam. So normally, as you know, that if you play with your friends, your classmates, then normally game would be a draw, right? No one would be able to make a win because the number of possibilities are just very less. That is just 9, 8, 6, 7, 9, 8, 7, 6, 5, 4, 3, 2, 1 like that. Okay, but if you want computers to understand gaming, we'll have to teach computer, that means robots, about these possibilities. If we write the program in a way, if we write the program to teach these possibilities, computer will start understanding the game. Okay, and let me tell you some about some of the games which computers have learned and they have defeated humans in that. You want to know about those games? Okay, let me show some of those games. So here I share my screen. Okay, so here, okay, this is not actually a game, but as you see, here is a machine. This is actually a machine, right? So in this machine, it is actually developed maybe some 300 years back, just to fool someone. So what they would do, there would be a player here, and yeah, okay, yeah. So there would be a player, and I will not be able to use the mouse with this. Yes. So here is a player. This is the player, and the player will be playing the chess. And inside, there is a person who is hiding into the machine and will move the pawns and queen and knights and everything just beneath the board, the chess board. So people would understand that, oh my God, there is some machine playing the game. It was not actually intelligent machine. A human inside, the hidden human, was playing the game. It was called Mechanical Turk. What is that? Mechanical Turk. Okay, so that was just maybe one of the first machines used to play the games. Do you know what this game is? Any of you? What that game is? Yes, Satyam.
Bacchus?
Sorry?
Bacchus?
No. Okay, let's play a quiz today. We have so many games, some 10 or 12 games. I'll ask names of each of those. Let's see who gives the maximum answers. Okay? Ready? Okay. So this game, I'll share the screen again. So this game is called Tower of Hanoi. Tower of Hanoi. Here. Or it is also called Tower of Brahma, because it was invented originally in India. Then some European, some French person reinvented this game before maybe more than 100 years. But originally it was developed in a temple in India. So it is called Tower of Brahma or Tower of Hanoi, where you have this disc, and you'll have to move this disc into the pillar number 3, as shown in this algorithm, from here to here, as you see. But the rule is you cannot put the bigger disc on top of smaller disc. You cannot do that. That is the rule. And with that, you will have to transfer all the discs from one bar to another bar with minimum iteration. Computers now can do this very easily. Actually, computers can do, even not today's computer, even computers before 50 years, they have done this very efficiently and easily. Next, what this game is, who knows what is this game? Yeah? Anyone knows? Yeah, anyone knows? So this game is called the Mastermind. What is that? The Mastermind. See here. Mastermind is a brilliant game. You should play this. Computers have won the Mastermind game against human in the year 1970. Scientists have written, computer programmers have written the program, software, to win the Mastermind game against humans. Tell me, which game is this? Which game is this? Can anyone? No. None of you. Okay, let me tell you then. So this game is called backgammon. Okay, backgammon. And computers have won this game against human in the year 1979. They can play this game as well. With dices and this. Which game is this? Anyone can even say which game is this? Yes, Bhavyesh.
It is Connect 4.
Connect 4. Wow, that's good. Correct. Nice, Bhavyesh. Big hands for you. This
Thanks.
is for Connect 4. And as you know that in tic-tac-toe we had some 6 and 8 positions, no possibilities to move. Am I right? You know how many positions, how many possible moves in Connect 4 we can have? This many. Read this number. Read this number. It's too large, no? It would be some 45, 4, 5, 3, 1, 9, 8 billions and billions of possibilities. But computers have won this against human in 1998 as well. Now, next game is this. Tell me, which game is this? Yeah, which game is that? Dishan?
Checkers.
Checkers.
It's my favorite game.
It's your favorite game. That's good. Very good. You play checkers regular.
Yeah.
Okay, that's very good habit.
Sir, just before you said backgammon, I remembered that, so I could not answer it then.
It's okay, fine. So good. You know that. Dishan, big hands for you as well. This is checkers. Correct. Now, checkers is a kind of, as you can see, it's a mixture. Yeah, it's a mixture of maybe chess and carom disc. Okay, it has this 8x8 board and a program called Chinook. This is the name of that computer program, Chinook. In 1994, it won against the international winner of checkers. Yes, international winner of checkers. Now tell me, which game is this? The easiest one. The easiest one. Who can say that? Okay, Havisha.
Chess. I can play it with my father.
Oh, very good. Chess. Chess was considered one of the complex game, and people thought that we will not be able to write the programs for chess. But as you know now, in the mobile phone as well, you can play the chess, and mostly in computers in mobile can beat you in chess. Am I right? The complexity level is so good. But let me tell you about this particular software, this particular machine, which was specially made to play chess, and the machine's name was Deep Blue. Deep Blue. See, it is written here. The name of the machine was Deep Blue, and it played the chess against Garry Kasparov, the grandmaster of chess. One of the best player in the chess ever happened. And right, so Garry Kasparov was one of the grandmaster, and Deep Blue defeated Garry Kasparov. And with the speed it had, the Deep Blue can think more than 200 million moves in a second. 200 million moves in a second, up to 6-7 level of future moves. And what normally when we play the chess, right? When we play the chess, we think about the future moves, no? If you are a good chess player, you think about the future moves that I am moving the pawn, then he or she would move the knight, and based on that, I'll move my bishop. You think like that. With this combination, this Deep Blue computer can think up to 7 levels and up to 200 million possible moves just in 1 second. That's too much, no? I think many people want to say something. Let's ask Dishan.
Blue also play against Bobby Fischer?
Yes. Then Deep Blue.
Did it win?
And there are so many computers already developed. Deep Blue was first developed in 1997, so it is too old, in fact. And then after, so many advanced chess playing computers are already made.
Did it win?
Sorry?
Did it win against Bobby Fischer?
Yes, yes. Yes, Viram?
Sir, can I tell the next game name?
Okay, you have already seen that. Yeah, tell me. Yes, yes, you can tell me, Abhiram.
If you're sure, I can tell, sir.
Oh, okay, okay. I'll show that. You want to say something, Bhavyesh?
Yes, sir. There was an app called Chess Kit, and there would be like three robots, and there would be three challenges. The first robot is easy, the second robot is a little bit hard, and the third robot is so hard. And I used to play that, and always when I was in the easy part, the robot used to win.
Okay, okay. Good. Okay, I'll share the screen now, and we have the next game. What this game is? Yes, you can say what that game is. Yeah, Darsh.
Othello.
Othello, yes. That game is called Othello. It's really good, Darsh. Nice. You know about it. Good. So I'll share the screen. See, this game is called Othello, also River-Z. There are two names of this game. One is Othello, another is River-Z. And a computer named Logistello. That computer won this game against human. It has an 8x8 grid as chess, but there are 10 raised to 28 moves. That means you put 28 zeros behind one. Can you guess that number? How big that would be? 28 zeros behind one. Yeah. It can, so this game can have this many possible moves. And computers, we can program computers to play this game as well. Next, our next game would be, here it is. Yeah, tell me, which game is this? Yeah, does anyone know which game is that? So this game is called Avari. And the computer in 2002 defeated humans in this game. This game is actually 3,500 years old African game. And this many possible positions can be there when you are moving your disk or your beam. It's too big, no? Now our next game is this one. Tell me, which game is this? Which game is that? Any new hand? Yes, Sarika.
Sir, is it Alphabet Trickster?
No. Sai.
Scribble.
Scrabble. Good, nice. That's for you. This game is called Scrabble. I'll share my screen. This game is called Scrabble. And it has some 15 by 15 grid and a computer called Quackle. defeated humans in this game. You know, the important part of this game is it can have some hidden information. Hidden information means you don't have everything in front of you. You don't have anything in front of you, right? The information is hidden. Something like the playing cards. Something like the playing cards. You don't know what playing cards the opponent will have, right? The play cards. You don't know what play cards the opponents will have. So same in the game of Scrabble, there would be some hidden information which the opponent cannot know about. But there is program which can defeat humans. Not when we talk about defeat humans, it means when computers, the programs defeated the world champions of those particular games. Okay. Now here is the next game. Tell me, which game is this? This game. So many buttons, right? Stones. Which game is that? And this game is called very easy name. Go. This game is called Go. But the name is so easy, Go. But it's being considered one of the most complex game because the possible moves in this game are more than the number of total atoms in this entire universe. Yes. The total number of possible moves in this game of Go is more than the number of atoms in the entire universe. We already know that our body, your body is made out of billions and billions of atoms. And we are talking about all the visible universe. That means all the planets, all the stars, air, everything. Not on the earth, but outside as well. Even in the sun, the Jupiter, the Mars, and beyond that, beyond the solar system, all the visible universe, total number of moves are more than the total number of atoms in this universe. This is being considered one of the most complex game, widely played in Korea, in Japan, in China. But computers, there are now programs, there are computers which can defeat humans in the game of Go as well. There are stones and 19 by 19 grid and a program called AlphaGo. In 2016, it defeated the world champion of Go. Now the last game that I am showing you, be very quick as I know everyone knows about it. Which game is this? Everyone should know about that. Any new hand? Okay, Jen.
The Rubik's Cube.
Rubik's Cube. Yes.
Sir, I have one at home.
Yes, you have. Good. How many of you can solve Rubik's Cube? How many of you have solved Rubik's Cube? Avisha, Abhinav, and Yana, Saloni, Dharmansh. Good, nice. You can solve this. That's good. What is the world record of solving a Rubik's Cube? How much time do you need to solve a scrambled Rubik's Cube? How much time do you need? Maybe 10 minutes, 15 minutes, 1 hour, 2 hours a day, right? What is the world record? World record of Rubik's Cube. Yes, Dishan?
4.26 seconds.
Correct.
Yes.
You are right, Dishan. Someone has solved the scrambled Rubik's Cube in 4.28 seconds. Unbelievable, no? Right? Just 4 seconds. Done. Yes. But, what is the record for computers? A robot has solved this. A robot has solved this in 0.38 seconds. Yes. 0.38 seconds. You want to see that? I'll show you the video. So here you see a Rubik's Cube. So there is a robot specially made to solve the Rubik's Cube. And it has the cube here. Yeah, it has this, scrambled Rubik's Cube here, right? See, it is scrambled completely. And then there are some robotic hands and a computer vision system. Using cameras, it will detect the colors and we'll see if it is done or not. And now I'll play the video and see what happens. Ready, all of you? Ready? Yeah, I'll play the video now. See.
Solving in 3, 2, 1.
Done. Could you notice even when it did? One more time. See this.
Solving in 3, 2, 1.
Okay. Now you see this in slow motion.
Yeah.
See, it's slow motion now. One more time in slow motion. Yeah, one more time in slow motion. And now again, even slower. Super slow motion. See. Yeah, that is super slow motion.
Three, two, one.
Yeah. 0.38 seconds. That means 1/3 of 1 second. Faster than the eye blink. Yeah. Now let's have some questions from from Dishan.
I wanted to say that with the human, my dad told him maybe a thought before what's gonna be, and then when they counted, he just fixed it.
Yeah, good, nice.
And it takes time for him to fix it. The robot can just fix it very fast.
Very fast, correct. Yes, Abhinav.
There, one guy, okay, in 5 seconds with one hand, he finished the whole Rubik's Cube.
Who? You?
No, one guy.
Oh, okay. Yes, Abhiram.
Sir, Felix Zemendek solved the Rubik's Cube in 4.28 seconds.
Yes, yes, correct. Dharmansh.
So in a video, I saw that one man, he had like 15 blocks of Rubik's Cube and he solved in like half an hour.
Yeah, possible, yes.
That in the video, I saw that in 3 seconds, that Rubik's Cube was solved. How could they do that?
So, okay, first of all, to correct you, Yana, it is not 3 seconds, it is 0.3 seconds.
Oh, okay.
Even shorter than that. And it is possible through first technology is computer vision. That means camera programmed cameras. So whatever they are seeing, whatever the cameras are seeing, it is being processed using the software to know what colors are there at the cube, what palettes are there. And then the mechanical hands. The motor and camera are moving so fast, it is programmed so fast that it can solve the problem in 0.3 seconds. That means third part of 1 second. Okay?
Sir, but sometimes they could edit also.
No, that is not edited. That is world record noted. So that is not edited. That is not just video editing. See you then. See you in the next class. Bye.
Bye.
Bye everyone. Bye.